Let's jump right into the PoolParty Semantic Classifier. I'll guide you quickly how to set up and test it. And, at the end, I'm going to show you an API call so you can see how easy it is to create it, and what you get in return. Let's assume you expect a load of documents in the educational space, and you want to sort them into 3 distinct categories. PoolParty's Semantic Classifier will do most of the job for you. All you need to do is to train it. And since it's semantic, we're gonna use a thesaurus and documents as food for the machine learning algorithms. So, first you start out with the thesaurus. Let's briefly look at it. Its preferred, alternative and hidden labels are used as additional learning material. We also do a corpus analysis based on referenced documents. Once you get a green light from PoolParty, you're able to use its results for the shadow concept feature of the classifier. Now, we're on the Classifier tab. Here you'll start with setting up the training boxes and upload documents. It's a simple create, upload, or drag and drop procedure. You can add more documents later, or delete afterward. You will use them later as food for the classifiers. You also see a test box. I created it and uploaded documents up front. More on it later. Okay. Now let's get to the core of the PoolParty Semantic Classifier. Please look carefully and experience how easy it is to configure a classifier. You start with a name for it. It should be comprehensible afterward, particularly if you create many. Next, you need to create the categories you're interested in. The documents you are going to classify will be labeled with these categories. And of course, the training sets should teach the classifier what you're after. In our case, we create the 3 categories: math, science, and language. In a next step, we choose, from the Configuration tab, the machine learning algorithm. Deep learning for our first classifier. We leave the vectorizer untouched but decide to go with the tenfold cross-validation. As training material, we reuse the boxes we built before and connect them to the categories accordingly. Well, let's create a second one. The steps are, as expected, identical. We create the categories we're interested in for the final results. Except for this time we use linear support vector machine as the machine learning algorithm and 5-fold cross-validation. Now we switch to the so-called Features tab. Here we just select terms, no concepts or shadow concepts this time. Now let's check if everything is set up the way we want it. Better check the first classifier as well. The classifier settings are fine. Now, let's check the so-called Features tab. Here you decide to just use terms like we did it for the other classifier, or if you want to semantically enhance the training material with concepts and shadow concepts from the knowledge graph. For the latter, you need the results from a corpus analysis. And now, let's fire up the first training session. It'll take a bit of time, depending on the size of your training sets and the number of categories. Well, here are the results. And they are actually nice ones. Roughly 400 documents were used as learning material along with the knowledge graph. And yes, we got an F1 value of 97%. Actually, everything beyond 70% is a good starting point. The general performance is also very nice. Please look briefly at the results in the table. Now, let's train the second classifier. And here are the results. Oh. General performance is higher, the number of documents is the same of course. But remember, this classifier is trained solely on the documents. No knowledge graph has been fed. We can see that the F1 value is a bit worse than the one from the first classifier, which also consumed the knowledge graph. At this point, I want to emphasize that we recommend creating a number of classifiers with different settings and then to compare the F1 value. Then go with the best performing one. A final step is testing your classifiers against the chosen categories. Hence the test configuration. Let's briefly look into it. Check the classifiers you want to test, then select the test box and run a classification job. And here we go. You can see the results, and they are different in a few cases. At this point, it makes sense to check out the actual job of the classifier. You do it by looking into a document with controversial results. In the actual document, you'll see terms and concepts, in green, that have been used to classify it. In our case, it's quite evident that the concepts helped to classify this document correctly, whereas the pure machine learning algorithm failed. The concept, actually a multi-term, English language, was nicely detected. A clear indication of the benefits of applying a knowledge graph. Now, let's conclude this demo. Our session covered the actual usage of a classifier. Well, we set up and tested the classifiers in the graphical user interface. Now, the actual classification job runs via the API. Let's quickly look at the syntax of the API call. You need the classifier ID and the project ID, that's it actually. We use a few other parameters to reduce the amount of data which is returned from the server. Okay, here we go. I prepared the call already. You can see the post request, the authentication, and the file we sent to the classifier. And voila, a label has been returned. Bravo! Classification accomplished. Thank you very much for your attention. We hope we were able to give sufficient details into how the PoolParty Semantic Classifier works, and how easy it is to actually configure it. We also shed some light on the benefits of introducing semantic web technologies with machine learning algorithms. If you want to try it yourself, please sign up for a trial account and give it a go.